So thank you, Nabila. It's good to see you again. It's been a while. I'm Brendan Quinn, a developer in repository and digital curation at Northwestern University Libraries, Adam and Karen's coworker. I'm a 37-year-old white male with red hair and a mustache. As I get older, it's more like salt and paprika as opposed to the redhead I used to be. I'm sitting in front of a virtual background showing Northwestern's Weber Arch in the snow because I'm in a real winter mood right now. It's snowing outside of my window. Today I'll be giving a brief introduction to Meadow, our new digital repository application built with Elixir, React, and GraphQL in the middle. I was trying to max out the length of my title for Sketch, but I didn't hit it. Maybe to answer Daniel's question that just came up in the Q&A. So I'm going to take kind of a high-level overview of the Meadow application that implements that batch edit functionality we just looked at. So why we went down this path, what our project goals are, and some high points of functionality we've developed so far. First, I'd like to introduce the rest of our development team. So there's Adam, Divya, Michael, myself, Veronica, David, and Karen. We do the day-to-day development on the project. A special shout out to Laura Alanya, who some of you may know, our digital preservation librarian, recently, a couple weeks ago, got a new job. So thanks for everything, and we wish you the best. And then additionally, I'd like to thank David Schober and Carolyn Casey, our team leadership, for giving us the chance to see how far we can go with a new language and a new framework for our team. So thanks. So here's some high-level overview of the problem we're trying to solve, as well as our high-level goals. And sorry for this slide is kind of busy. There's a lot of information here, but the slides will be posted. So if you want to look in more detail, feel free to dig in and ask questions later on. We're on Slack all the time. So you can see in this diagram, we have kind of our workflow from when items are scanned or digitized and all the way through to when they're published into our digital collections front end. And so what we've had in the past is, you can see the red bar at the bottom is we have digitized materials that are stored on network storage for months or even years at a time without being tracked by any kind of a system. Now, currently, those items are ingested into Donut, which is our Hyrax application. So our new focus is on, and also that red area we lovingly call the danger zone, where our items aren't being really tracked except for manual processes and spreadsheets and stuff like that. So what we are aimed is to get items out of the danger zone and into a system that we manage, and then describe those materials while they're in a place of relative safety. So our goals for the project are preservation first design. We wanted to build a system with digital preservation best practices in mind from the outset, rather than backfill features later on where they might not fit. Our users also wanted transparency into preservation concerns, so we developed UI components for increasing that kind of visibility of things like checksums, checking for existence in the preservation bucket, on demand, things like that. There's a lot more to come there, but that's what we have so far. We wanted a fast and scalable ingest pipeline. So like Adam and Karen were saying, our power users ingest thousands and thousands of records at a time, and we wanted to be able to support that. The ability to batch edit metadata, those were those wonderful slides you just saw. And so we wanted concurrency and fault tolerance. Those are things that are provided by the Elixir programming language, which I'll get into in a little bit. But the Elixir and AWS services we use allow us to write software that executes tasks in parallel, which speeds up processing. And the fault tolerance mostly comes from Elixir's supervision tree, which gives our applications the ability to recover and retry when inevitable errors arise. And then we also wanted to focus on having a nice development environment. So we prioritize building using Docker containers and making local seed tasks to build out sample data quickly and easily. So with just a few commands, you can have a local dev environment with many thousands of records with metadata that you can test functionality or check for bugs and things like that. So I'll go over our architecture overview. First, some terminology. There's a lot of kind of terminology going on here, so I'll try to break it down in a sort of simple way. So we have Elixir, which is a functional dynamic programming language with immutable data running on the Erlang virtual machine, also known as the Beam. We use the Phoenix framework, which is built on Elixir, which is a web framework for Elixir applications, similar to Ruby on Rails. We used a JavaScript front end, which I was like trying to think of a definition for JavaScript, and I came up with just the language of the web, for better or worse, LOL. And we use React and reactive search to build out our UI components and search on the front end. We use a GraphQL API. GraphQL is a query language for APIs and a runtime for fulfilling those queries with your data using a type system. And then we use Absinthe, which is a GraphQL implementation of our GraphQL implementation for Elixir, which has integrations for Elixir backend and JavaScript front ends. And then our search engine we're using is Elasticsearch, similar to Solr. Many of you, I'm sure, are familiar with. And we use a whole host of Amazon Web Services, many more probably than I could list out here, for our databases, our searches, our container hosting, our routing, everything basically is powered by our web services. And then Docker for containerization, both locally and in deployment. So just a little bit about why we chose these things. Elixir has a Ruby-like syntax, which made for a relatively smooth transition for us. It has a lot of great built-in features that match our needs, like data immutability, process model, pattern matching, the pipeline operator, which is kind of a cheeky joke in my slide, which is kind of what the pipeline operator looks like. First-class documentation, so there's documentation everywhere built in. The XUnit testing framework we've gotten a lot of use out of, and it's really great. And also the library ecosystem for Elixir has come a long way. It's a relatively new programming language, but a lot is out there already. So things like Ecto for our database, Elasticsearch, XAWS for communicating with the AWS SDK, and other things that don't start with the letter E. In terms of JavaScript, we have actually a lot of experience with JavaScript. We have a React application running in production currently for our digital collections front end, so it works well for us, and we decided to keep using it for Meadow. And its component paradigm gives us the ability to build and reuse discrete pieces of functionality, which is really nice. And then GraphQL is also new for us, but it provides an API layer between the front end and back end that allows us to develop features independently, especially using mocks and things like that. The Absinthe implementation we use has integrations for the front end, back end, so that's really nice. It provides excellent documentation for end users, so there's a graphical playground user experience you can use, like if you go to /API/graphical on Meadow, you can see and use our GraphQL API directly. And it provides the queries and mutations we need to query and update our records, as well as subscriptions that power WebSockets for real-time messaging. And for the visual thinkers among us, this is kind of a diagram of what we have in place in AWS. It's definitely simplified, and I'm ignoring things like networking and security. And just to keep it as simple as possible, we have in the center of this diagram is an Amazon ECS container task. So it's a Docker container, which is where our React graphical or GraphQL and Phoenix/Elixir application lives. So it runs in a Docker container as an ECS container task. And then outside of the container task, we have microservices that our application uses to communicate with, to do work, store data, send messages, grab users, things like that. So I'm going to change gears a little bit here and talk about, this is a Meadow data is kind of a joke we've had since the beginning of the project. So I'll talk a little bit about our data modeling. Our challenges we have in our HireX application currently, we have pretty complicated data models for our work records. We have 50 plus descriptive and administrative properties. We have many properties that are backed by external authorities and local authorities. And then we have complex UI components and functionality we need to support that sort of glut of information to make it easy for our end users to see and manipulate. So how did we implement this data model? In Elixir, there's a library called Ecto, which is the most prominent library for data mapping and database interaction in the Elixir ecosystem. For the Valkyrie users among us, a lot of the patterns that Valkyrie implements were inspired by Ecto, such as chain sets and the repository pattern that uses adapters so you can switch databases and things like that. So Ecto came up a lot in our early conversations about Valkyrie, which is, it's been fun to use Ecto for the past year and a half. We're using the Postgres implementation of the Ecto SQL library as our adapter, but you don't even need to use the database to use Ecto if all you want is change sets and validation, things like that. We have sort of standard library data models for works, file sets, and collections. Those are implemented using Ecto schemas that provide relationships like has, many, belongs to, all that standard stuff. And then we also use, Ecto provides embedded schemas where we store our administrative and descriptive metadata as JSON-B directly on the work and file set records. So it's nice to use because Ecto tries to protect you from N+1 queries by forcing you to preload associations manually. And JSON-B stored as embedded schemas lets you sort of bypass that and lets you avoid the need to preload the associations all the time. It does have sort of a flip side where it makes querying and updating a little bit more cumbersome, but in the interest of time, I'm going to kind of skip over that for today. And then also Ecto queries and chain sets underpin our GraphQL API for building out our front-end queries and mutations. So in the previous presentation, Karen and Adam went over batch editing, but I kind of wanted to go into depth about our batch ingest pipeline. So how do we get our records into the system in order to be described and edited? So I sort of chickened out on doing a live demo, so I made pre-recorded animated GIFs or GIFs, whichever you prefer. So what you're going to see here is sort of a fast-moving demonstration that I'll try to describe in real time, where you're going to see our ingest process through the front end of our Phoenix and React application. All the data that you see is going to be powered by GraphQL queries, mutations, and subscriptions. So without further ado, here it comes. I hope you can see it. So what's happening is there's an ingest project where someone's going to add an ingest sheet. We're going to choose the spreadsheet that we're going to load up and then hit the upload button. So what's happening now is we're going to check to see whether the files are in the staging bucket in Amazon S3 and do some work on the spreadsheet, which I'll describe in the next couple of slides, and then process our works and file sets and run them through our ingest pipeline. You can see the sort of the real-time WebSockets happening there. And oh, I think my GIF may be oh, there we go. So then you can see the successfully ingested ingest sheet in our system, and that last little screen was our batch edit interface. So I'm guessing most of you have seen a spreadsheet before, but this one is ours and we like it. The important thing to note here is that the first two columns, the work accession number and the accession number, are used to group works and file sets, which are then run through the ingest pipeline. And the file name we end up storing as S3 metadata attached to each object in our preservation bucket, because the S3 keys for those items end up being a pair tree checksum, just like Fedora binaries. So we store the original file name for preservation purposes as S3 metadata. And the description is more for just internal tracking purposes. So you can give yourself kind of hints as to what these things are. And then we have AM and PM roles, so access and preservation roles for our works. So yeah, it's a really simple spreadsheet. There's not any descriptive metadata to speak of. A lot of times we'll have scanned many thousands of records or digital objects for a collection, and they don't even have titles and creators and contributors yet. So our whole goal here is to take that material and get it into the system before we even have any descriptive metadata applied to those records. So yeah, here's our spreadsheet. And then this next slide is kind of about how our backend breaks that spreadsheet down and sends it to our pipeline. So on the left-hand side, you see it represents the rows of our spreadsheet. The next column is grouping the rows by work. So that's based on the accession numbers. We kick off progress for each sort of work file set grouping. We create work and file set records and transactions that can succeed or fail together. And then once those things are created, they're sent to the pipeline for processing. So the way that we handle our pipeline is through an Elixir package called Broadway, which allows you to take Amazon SQS messages and pull them to process in Elixir modules. And we wrote at Northwestern a wrapper library around that called Sequins. So the joke is about Broadway and Sequins. And SQS and SNS. So what the job of Sequins in Broadway is to sort of add SNS pub sub to the Broadway pipeline. So we have it has a lot of more opinions about the pipeline than Broadway does. Broadway gives you a lot of flexibility, and we didn't need that flexibility, so we wrote a wrapper around it so that we can have sort of default behavior and not have so much ceremony in our actions that we define for the pipeline. So at a high level, Sequins provides utilities to create queues, topics, and subscriptions that support the pipeline in Amazon SQS and SNS. It allows you to set up the infrastructure. So it creates the queues and topics and subscriptions using the AWS SDK. It defines a standard behavior for pipeline actions. So each action, which I'll go into in a minute, only needs to define one process function that returns a status and optional data. So you do some work and you say either okay, retry, or error, and optional data. In our case, it's usually just the file set ID. It allows for flexible configuration for concurrency. So depending on the system, you can really have a lot of concurrent processes or few, that kind of thing. And it's also a supervised Elixir application with built-in fault tolerance. So it sits in the application supervision tree, and if processes fail, they can be recovered automatically and back to a known good state. So those are the tools that we use to build it out. But then, so the next slide here is a kind of high-level visual diagram of what our ingest pipeline looks like. So I'll try to describe it as well as I can. The diagram on the left, we have three vertical columns. On the left, you have the Amazon AWS Simple Queue Service, or SQS. In the middle, you have our Meadow Elixir application. which is using Sequins Broadway for defining our ingest pipeline. So this is code we wrote in the middle. And then on the right, you have Amazon's AWS Simple Notification Service, which is our pub sub topics and subscriptions. So the column on the left is SQS, which is our message queue. Each queue in the column is a producer from which messages are pulled by our application. The center is the ingest pipeline for Meadow and its actions. So at the top, you see the work creator module. It sends file set IDs to the pipeline module, which has a kickoff function that's used to start the processing pipeline for each file set by sending a message to the Meadow ingest file set queue. And then below that are actions that are the quote unquote processes in the system, the parts that do the actual work. So each action updates the file set's progress internally in a database table, does some work, and then sends an update that we use as a basis for publishing WebSocket notifications and power things in the UI. And then after the work is performed, the actions send process data to an SNS topic. So on the right is the AWS Simple Notification Service. So you can see the list of topics: Meadow ingest file set, Meadow generate file set digests, etc. So the actions send messages to topics, which in turn deliver those messages to all subscribers on the topic. In our case, subscribers are the SQS queues in the left-hand column. Importantly, we use subscription filters to send messages back to queues that have a retry status. So if something doesn't work, they can go back to the previous pipeline queue and retry. Otherwise, messages are sent to the next queue in the pipeline. Though we haven't implemented it yet, it would be actually pretty trivial to add other subscribers such as AWS Lambdas, arbitrary webhooks, or even email or SMS messages who wouldn't want to receive a text message each time a pyramid TIFF is created in a batch of 20,000 file sets. So in the next demonstration, I'm going to kind of show what I showed in the first animation, but this time sort of peek under the hood a little bit to see how our GraphQL subscriptions can be monitored through the graphical playground. And we'll see a little bit more about the actions that are being performed on the file sets for a particular ingest sheet. So you can see on the left is the front end, and on the right is our graphical playground. So you can see the ingest progress all the way at the right-hand side. So there's 41, 62 completed actions, 49% complete. And so you can actually see the GraphQL subscriptions through a user interface, which is then used to power that progress bar in the React component on the left. So our system has sort of allowed us to have the ability to see a lot more information and at different levels than we have ever had before. So you can interact with these APIs through command line interfaces, through these UIs, and yeah, so we have a lot more visibility and information than we've ever had in terms of our processing pipelines. So it's been really great. And then I'll sort of end with a little bit of to-dos. Like all we have left is really to finish up our batch editing that Karen mentioned in the previous presentation. We're about 80% done with that. And then we have to deal with eDTF dates because there's no eDTF implementation for Elixir. So we're probably going to use what's called an Elixir port to call out to the eDTF.js library so that we can meet our metadata specialist needs in terms of dates. But besides that, we're right on the edge of launching probably within the next few weeks or so. And that's all I had. Thank you so much.
Thank you, Brendan. It was a really great presentation. There are two questions. One is
sure.
more like a comment. So April is saying, I have used InVision to help with generating feedback. It allows the interactions to be present when your wireframes, within your wireframes, as if it was the real thing. It's easy to use and get up and running. There's a free account setting, but with limitations. Also, Figma has been really great to use, from low fidelity wireframes to mockups when trying to elicit feedback from all stakeholders, internal or external, through the entire design process. Great presentation. Thank you.
Cool, thank you.
And, mhm. And then there's a question from Justin. How does Meadow ensure digital preservation? Are you relying on S3 entirely?
Right now we are relying on S3 entirely, and we're going to be using the geographic distribution features of S3 for that. And we also have local Isilon storage, but it's just gone through a pretty massive upgrade. And so that's definitely in the queue for work coming up, is replication down to on-site Isilon storage at the university. So yeah, we generally think of digital preservation as more things that humans do, and sort of allow people to make good digital preservation decisions based on information in the system. So one of the things that our users definitely ask about is, can I make sure that the file is in the preservation bucket by just looking at the UI, things like that. And we've definitely been talking about Amazon's new fixity checking service that they just launched in the past few weeks. So we're looking at implementing those features. And yeah, thanks for your question, Justin.
Mhm. Thank you. There's one more question. Do you utilize a shared design library for your React components between your Meadow application and your digital collections app? If so, how do you manage that code from a single source?
I hope maybe Adam's still online and he can maybe answer the question about our component library. I have definitely less interaction with that aspect of things on the project. I'm more on the Elixir backend side of things, but we do have a whole system in place for managing our React components. And Justin, I can definitely link you the notice that went out recently about the fixity service. I'll do that right after this.
Okay, thanks.